Hi, James Jones from the Mid-Pacific ICT Center in San Francisco at our 2010 ICT Winter Conference. Got a lot of great people here. One of them is Dave Nelson from VMware. Hi.
Hi James, thank you. I'm Dave Nelson and I work for VMware. I'm based in Colorado. Our offices, headquarters are here in Palo Alto.
So you get to do some work while you're out here besides just helping us understand VMware better.
Yeah, indeed. The last few days I've been in our Palo Alto offices and having an opportunity to meet face to face. So this was really a great opportunity for me to come out because I was able to get some FaceTime with my colleagues out here as well as having the opportunity of presenting at the conference.
Good. Well, VMware and virtualization are red hot. And for any members of our audience who aren't total geeks and don't know exactly what that is, can you describe what virtualization is?
Yes, I can. And it's always interesting when I speak with people who are not in the IT industry and try to explain it to them. But interestingly enough, it's a concept when you explain it in terms of the fact that typically you have a physical machine. On top of that, you have layered the operating system, and then you have applications on top of that. And for a long, long time, that has been essentially the structure. And what virtualization does is it provides a layer of abstraction between the hardware and the operating system and application, so that you then have a virtual machine, and you can have many, many virtual machines on one physical machine. The advantage there is that typically you'll find that in a situation where you're not virtualized, the server utilization is somewhere around 10 to 15% on average. And so what you're doing then is you're spending a lot of money for hardware. You're spending a lot of money for air conditioning and electricity and the floor space and all of that sort of thing, and you're only getting 10 to 15% of the return on that. So by virtualizing, what ends up happening is you have many, many virtual machines on top of one physical machine. All of these virtual machines think that they own the physical resources underneath it. In fact, they are being provided by VMware's abstraction layer, what we refer to as in our latest release as vSphere. And so that then provides all of the resources to the operating system and ultimately supply the applications. And that would be the physical things are CPU, memory, storage, and networking. And in doing that, you can reduce the number of servers that you need depending upon the utilization and the criticality of the application that you're running. A lot of times we'll see that you'll get a 10-to-1 reduction in terms of number of servers, but sometimes you will see servers that have 40 virtual machines on it, as an example. So it's a tremendous savings there. It's also a savings not only from the capital expense point of view, but it's also a savings in the operational expense. Because because you need less air conditioning and electricity and so forth, that's one thing. But in addition, because you're doing things in a virtual world instead of a physical world, you need less people in order to manage that. And so you end up with reducing cost, and interestingly enough, at the same time, and I hope I'm not blabbing on too much, but at the same time, what's happening is that you're increasing reliability and availability. Because in the physical world, when something fails, basically the system comes down and your application stops running. In a virtual world, you can, while the application is running, while the operating system, the virtual machine is running, it can be moved from one physical machine to another, and therefore keeping 100% uptime.
So before we get too much further, let me see if I can summarize and if I'm understanding correctly. So in the world of IT until now, we've had dedicated computer server resources to specific functions or tasks. And having that dedicated computer resource costs a lot of money, not just to buy the machine, but also to operate it, to provide space for it, to provide cooling, to provide electricity. And this technology allows one physical resource to actually be shared by many different tasks and services, so that you don't require as much equipment and you can lower operating costs as well.
Absolutely correct. And there's one other very important thing that's happening right now, and that is the whole notion of cloud computing and the paradigm that it represents. It is essentially the next step in terms of computing. If you can consider virtualization is a very important technology in enabling that, and VMware is working, has set up a collaboration with EMC and also with Cisco, and we've created what we refer to as a VCE. And underneath that, what we have done is we have created a separate organizational entity that will provide cloud computing for anyone who wants to basically have one-stop shopping and all of the services and support available to them for doing their cloud computing application. Here, the primary thing that would happen is that a data center would use cloud computing to supplement what it has, the physical resources that it has. So consider that you have certain times of the calendar year or the calendar quarter where there are large demands placed on your computing infrastructure. And let's say that you're going to be releasing a new product, or you're at the end of quarter, and you're fearful that you'll run out of resource and you may end up with systems locked or crashed or whatever. Ultimately, you can provide the necessary provisioning through the cloud to be able to get the additional computing power, storage, networking, all of the resources that you would necessarily have to own if you were doing everything within the context of your data center. But now you can have this provided as a service. I like to use the analogy that electricity for your home. You may have the capability of generating some of your own electricity yourself. You may have wind, you may have solar, that sort of thing. But if you don't have wind and the sun isn't shining, then you reach out on the grid and get the power to do the things that you need to do. And interestingly enough, when you do that, you don't know whether the power that you're getting off the grid came from hydroelectric, or if it came from fossil fuel burning, or some other way of producing electricity. So
electrons are electrons.
Electrons are electrons, and computing is becoming computing. So the compute power that you will use in the future more and more, just like in the case of how we have used the internet and the web to extend the capabilities of computing. Now what's going to happen is that we will see that the physical resources that you have needed in the past in your own environment will be extended by virtue of the fact that you can get them through cloud computing and in a virtual sense.
So it makes good business sense for someone who operates their own services to adopt virtualization, because they lower their capital and operating costs. But it also enables cloud-based services that allow people to sort of stay focused on their core business competency.
Precisely.
And just let somebody else handle